Hello viewers and welcome back into the lab. This video should keep some of you happy. It's a teardown at last. Yes, it's been a while. Now this would have been out sooner, but I've been recovering from coronavirus for the last 2 weeks, so my apologies. Yeah, welcome to 2020. So we're going to be having a look at this thing I picked up off eBay, funded by my wonderful patrons. Now if you want to help us out and donate even just €1 dollar pound a month, that makes a massive difference to me to help carry on making videos for you. There'll be links in the video description if you want to be a patron. So this weird box from 1992 is a Bio-Rad MRC600. It is a, are you ready for this? A confocal laser scanning fluorescent microscope and imaging system. So there. Okay, I can shorten this to confocal laser scanning microscope, or CLSM. A little bit easier to say. Now, if any of you watch Mike's electric stuff, you might recall a long time ago we pulled apart a confocal microscope. So I'm aware roughly what these things are and roughly how they operate, I think. Links to his video will be in the video description as well, if you want to go and check those out. Now what he had and I have here are two pretty different things. Firstly, this is far from complete. I don't have any of the laser parts. I don't have the actual microscope stage either. We have only this box. Now I believe this is the optical control part of the system, which takes the laser input, does all the funky optical stuff as in scanning the sample and also receiving the image data back from it. So before we get too involved, let's take a wider view of what CLSM is. Right, now hopefully I can explain this. I've been reading up and I think I understand enough of the concepts to explain it. So in traditional microscopy we have the subject, a light source and the actual optical microscope. In CLSM we have pretty much the same setup. Only the light source is now a laser. The critical part is that the laser and the reflected or possibly fluoresced light off the subject both pass through two very small pinhole apertures. This allows this laser to be focused to an extremely small point, increasing the potential resolution. The light coming from the subject also improves as the aperture also removes any stray light that isn't part of the actual point the laser's actually currently scanning. So effectively it filters out any stray light, so I guess you would get a better dynamic range and higher resolution. The use of a laser also allows the focus to be altered in the Z-axis, and because of those pinhole apertures we can focus in and image parts of cells internally by slicing it. Now as the laser is focused to a small point and not just a splatting on the subject with a load of light, it has to be scanned across the subject, which means the laser is going to have an XY scanning system to move the laser beam around. So this box would scan the XY in a flat plane, and part of the microscope itself would probably move towards and away from this box to generate the Z or depth axis. I should also point out that the light coming from the subject travels up the same path as the source laser, but it will be split off to be detected. So what are we going to find inside this box? From our understanding of the principles and various markings on the box, we should have inside two photo multipliers, probably with a power supply to drive them. There is going to be various optical things to get the laser from the input port through all the apertures and out to the actual microscope. There will also be the reverse path, so there will be some kind of beam splitter, probably dichroic mirrors and the like, that kind of thing. We will also have the XY scanning system, so possibly two Galvo motors and mirrors. What else will there be? We're going to need a power supply. As this plugs into the mains, probably some signal conditioning, for the photo multiplier outputs and some control electronics for the XY scanning. Right, now that is quite enough waffle. Let's take a closer look at the actual box. But before we take a closer look at this, I would like to thank my channel sponsor, PCBWay, for supporting us. Maybe you're interested in building some electronics project yourself. Well, there is a huge range of pre-designed projects available on the PCB website, ready to purchase now. Whether you're a seasoned PCB designer or just a beginner and want to have your own latest design prototyped or mass-produced, then PCBWay have all the manufacturing options you could need, along with great service and fast production. Links to PCBWay will be in the video description. Go and check them out. Right, so let's have a look at the box. This was a lot bigger than what I expected. From the photos, it looked a lot smaller than this, and it weighs a lot too, and that surprised me. It's probably getting on for, I don't know, maybe 15 kilos, something like that. So it's a big old hefty, big lump of stuff. It's quite clearly all metal. It looks like it's all big sheets of aluminium which have been painted. This dates from 1992. There's a sticker on the back. I'll show you that when we get round to the rear side. Now, in terms of orientation, I've seen this in a couple of photos in different orientations, but the one that I've seen the most shows this sat like this on top of the microscope. Now, I think it can actually also be positioned so it sits alongside the microscope. So yeah, it can obviously be orientated differently. Now, given the weight of this, then obviously there's going to have to be some kind of big rig to hold it and keep everything aligned. Obviously, we're talking about seeing inside individual cells, so it's all going to have to be very rigid and very well made to support something that weighs like 15 kilos. We have a few controls on the front here. So we have power, scanning LEDs there. We've got channel 1 and channel 2. This on the top here, I'll show you this in just a moment, but we've got two photo multipliers, PMT1 and PMT2. So obviously we've got two channels here. Why two channels? Not really sure. Might go into in a little bit more detail when we look at the top. They appear to be identical channels. There's this knob is broken off on this side, but we've got channel 1, black level, two push buttons there. The covers are missing, so we've got black level auto. So presumably we've got some vernier controls for manual operation. We've got external something, I'm not sure what that is. We've got an enhance control knob, so we've got off, -1 to -4 and low sig, and then we've got 1 to 4. So I'm not entirely sure what that is for. It's just enhance.
Enhance 224 to 176.
So yes, not sure exactly what that is enhancing. Then on the bottom we've got auto gain, so a button there just to turn on auto gain, and some manual vernier controls there to set it manually. We've got a port here now. I believe this is where the laser light comes in, so there would be a separate box which generates the actual laser. Not sure what type of laser it is. Might be an argon. Not 100% on that though. Now, this does actually have a few graphics on here just to show you the light path, which is really handy. So from this port here, it's actually showing it being able to go into two directions. So in this direction, it comes up here, hits this mirror, and then comes back down to the, I think this is the output port's on that side. And then we have the beam coming back, hitting this mirror, and then down into this thing here, and then we've got a straight through path to PMT1, and then there's a mirror which points to PMT2. Now we've also got these little covers. It's just an aluminium cap. Nothing particularly interesting there, but I would suspect we probably have some sensors that you could probably put into there, possibly during alignment, I don't know, and then you maybe take them out and then put the caps on. I'm not 100% sure on that. If anybody does know, can answer some of these questions, I'd love to hear about them in the comments. So this thing here looks like it's just a cover. Now when I took it out of the box, this knob was broken off here, and it's sprung loaded. So I think if this was actually on here properly, you'd be able to pull this up and that would allow you to get this out. So what I'm just going to have to do is just pull it up, lift that up. So yeah, we just got a little spring-loaded plungery thing, which would have been retained by that. That allows us to take that off, and that is just an aluminium cap, and we've got another one of these ports, just like we do on the input. I suspect there's actually something missing just there, so I suspect there was another one of these over here, allowing you to put two covers on, but possibly it's been broken off. And finally we got these things here, these little plunger things, nicely damped, with some kind of graduation on, so you can obviously set something in a particular position. Maybe, I don't know, maybe it's like an iris control, I'm not sure. We'll find out when we open it up. Right, we've got a big aluminium plate on the back, and we've got some big hex bolts in there, obviously for mounting onto something. There's another big screw hole in there. Doesn't go through to that port. It's there's this plate here is actually really thick. It must be about 15 millimeters thick. So there's obviously a lot of weight in that. We've got the power input with a switch. This presumably is some kind of control port from whatever actually controls it. We've got two BNC outputs. Now I suspect these are the photo multiplier outputs, which would then go off to some kind of digitization thing, and a computer and all that. So a couple of warning labels and blah blah, do not open, best sticker ever. Here we are, caution laser, argon ion laser, 1 milliwatt max. Okay, continuous wave. So yeah, it's not a particularly powerful laser by any means. Interesting, it's 115 volts. Now this is actually a product that's made in the UK, and I've bought this in the UK, so why that's 115 volts, I have no idea. I would have expected that to be 240. And over on the front we've got what is obviously the output, because there's a nice big sticker there saying avoid exposure. Now this is all a bit, doesn't really seem like it's put together properly, or it's broken, or there's bits missing. I think there's also some kind of aperture in this, but there's no way to, there doesn't seem to be any way to actually close it. Once it's open, I don't know, it's all a bit odd. Get my screwdriver in. No, I can't seem to. I'll have to take that apart later and find out what that's all about. So that is a little cover for this. Can't really see anything inside. It's just if you look inside, there's just a glass lens, so I'm not sure what else is behind that. Now, as for getting inside, I think everything comes in from this end. Obviously that end has the output on, so that's probably not going to come off. The back is just one solid plate, so I think everything's mounted to that inside. The bottom's not really going to come off, but this plate here would allow this cover to come off, I think, because that just seems to be fairly lightly held in there. So there's a load of hex Allen screws on the end here, so I think that's where we're going to start. Ooh, no. Oh. Right, these are all very loose, way looser than what I would expect them to be. So this has obviously been opened. Now, whether that means it's not working, it's broken, or these things have just been opened at some point in their life, and the screw's not done up properly. Oh! Blimey! Well, that was well, it's definitely the way to get in it then. Big lump of amulite. Ooh, yeah, there's lots of lovely stuff in there. Right. Right, well, let's have a look. Oh, right, yeah, there's lots of stuff in here and it looks wonderful. Right, where do we start? Right, well, probably the best thing to do is just have a bit of a rummage around. So we've got a couple of ribbon cables running over to a PCB just under there. You can't see that at the moment, so that is likely connecting to these controls on the front. We have two sets of wires running over to two boxes where the legend on the top says we have the photo multipliers. Those have wires which run into two plug-in cards on the side here, and down to two BNC connectors on two devices down here. And you can't see this yet, but they are labelled Thorn EMI Electron Tubes Power Supply. So looks like we've got two power supplies for the photo multipliers. There's a back plane, looks like this down deep inside there, with loads of connectors on it. We've got a big power supply in the middle section here, and then looks like the optical stuff in the top. Right, I've just turned this round for you so you can get a slightly better view. So it looks like each photo multiplier has three wires going to it. We've got a grey wire, a small thin coax and a large coax. The large one comes from the power supplies. So the small one, the black one here, that is probably the output. And then the grey one, which snakes its all the way down to these boards here, or this single board in fact. I'm not sure what that one is. That might just be a turn on the photo multiplier or turn it off. It might be as simple as that. So we've got two of these boards here. Those are labelled MRC600 amp. So given we've got two of them, we've got two photo multipliers. These are probably going to be the signal conditioning and all that sort of stuff for the photo multipliers to send it out to the outputs. Now, interestingly, you can actually see here there's three coaxes connecting to one of these boards. Now, one of the connections comes from that connector on the back as well as the BNCs. So there's obviously some kind of analog signal coming into these from elsewhere, but I can't really tell from these wires which way the signals might be going. So I think what I'll do is disconnect all of these, take out these cards, and then we'll see where we go from there. So PMT2 is the top card, and PMT1 is the second card. Yep, they look identical. So this card connects to that single grey wire, which is literally just ground and one signal. MRC600 MISC functions. And we've got these larger boards, no other connectors on them. Lots of trimmers on that. So we've got a big heat sink and some large power devices. So I'm going to hazard a guess that that controls the XY scanning. It looks like we've got two identical ones. So one will do X, one will do Y, presumably. Yeah, just on looking at the legend here on these trimmers, we've got dampening, servo gain, integrator, PD gain, PD offset, attenuator, and we've got two voltage LEDs, plus and minus 12 volts. So yeah, there must be some kind of servo system going on there for controlling the scanning. Here you can see from this angle now, those two power supplies are bolted on the side here, Thorn EMI electron tubes. Yeah, that's a high voltage BNC connector there. Right, now I think possibly that this top plate might separate from the rest of it, allowing all the optical stuff to come with it. Apart from that box there, which is on the output window. So I'm not sure, there might be some kind of pass-through which goes down into that, because the optics travel in this plane, but then it needs to go downwards to get to the output. So there's probably some kind of something in there. So hopefully, if I take off these screws, this should be able to just come away, hopefully. But first, let's disconnect the BNCs for the photo multipliers. Okay, so here's what I'm going to try doing. These screws here all go down into the back plate. There's 3 on the front here, and then 2 on there for the front bit where the controls are. Now I think once I take that off, I should theoretically be able to lift the whole thing out. Right, that is all the screws, so let's see. Yep, looks like we might be in luck. Right, so that came out pretty easily. There was just a earth strap down here. So that is now separate. So we have the top of the optical assembly with the mirrors and stuff that were pointed out on the legend above. So we will have a look at that in a minute. So there's a couple of things which are kind of intriguing on here. First off, there's an interlock switch just here. I hadn't noticed that before. Obviously with laser stuff and high voltage, they're going to have interlocks in there. So that's just a micro switch. I've also noticed this here. So that a big screw thread at the back, there's actually a little window. That's connected with a wire, so that's obviously a motorized thing. So I'm not entirely sure what that is for. Right, I think next step is to take out this power supply, as it's covering up a lot of the stuff. I think there's just 4 screws on the back. So the voltages shown on here are +5, +15, -15, -5 and +24. Just disconnected that from the power supply and the thing's got a plug on it. Never mind. That board there is literally just a back plane with the connectors on for the boards that plugged in. There's another board plugged into a bottom connector which just breaks out the connections to the photo multiplier power supplies and what looks to be all the wires that go into this section here. What? Everything's been metric up until now. What? That is definitely, yeah. Everything's been metric all the way up to this point, and these imperial. So yeah, cute little photo multiplier power supply there, type MPS 1600N. I'll look that up in a minute. Now I've just noticed here, there's a little sticker here saying Linda. So hello Linda. Yeah, so we've got a nicely machined aluminium piece there, so it's been milled out to reduce the thickness. Looks really nice, that. But yeah, we've got a small control board. There's a few components on it. Just seeing there, not a huge amount to be honest, probably not worth taking to bits any further. The 10-turn pots are Spectral. Hardly surprising. Okay, so the next step, take out this optical assembly. Just need to disconnect these. Looks like it's bolted to the front panel. I think what I'll do, I think there is actually a cover that I can remove, but I think what I'll do, I'll just opt to take it out completely first. I think there's just a few screws on the front here, and then it should just come out, I think. So not really much else to see in here now. It's literally just mains, wiring, connection through to the back plane, power switch, the wires that went down to the connector on the back, this shutter thing, and we do have a lens on the front. I can see it just inside there. I had mentioned before about this assembly on the front. Now off camera I just had a quick play, and I think what has actually happened is the grub screw which holds it on had just come loose, but when it's on it locks it in place, and there is an iris in here. Now I think what this is actually a laser lockout system, so when whatever you attach onto this locks into place, it actually opens the iris. So there's actually two slots here, and I would imagine there's probably something with some prongs which go through, and it just bayonets into there, and the action of bayoneting the connection up actually opens the iris. So I'll just get you a little bit closer in, you can actually see. So we've got these notches here, so whatever would come in here, come in, and then you'd turn it, and then that would lock the thing in place, and then as you turned it, it would open the iris. So yeah, when you want to disconnect it, it would then close the iris as a safety thing. So let's take a quick look at the top optical assembly that I took off. So we have two large metal boxes there with the photo multipliers in. This was, I think, the laser inlet port. Now, obviously, without seeing the thing that actually plugged into this, it's hard to understand how this actually worked. It looks like it might have had several outputs, or you could potentially turn it to different positions. I'm not sure. Interestingly, there is actually a little shutter on this one, just there. I think that was actuated by that motorised shutter thing that we saw in the back. Now, if we have a look at the back of this and try and figure out exactly where the laser is going, it's not 100% obvious what is actually going on. So this, I think, is where the laser comes in. Now, that will actually also go to this mirror. This mirror bounces the laser down into the Galvo assembly for the scanning, and of course the light comes back that path as well. So I wonder whether this the thing that plugged into here had some kind of mirror arrangement in it, so the laser would come down and bounce that way, and the return path would come back through and pass all the way through this, off this mirror, up to that one, and then back down, and then back into this tube, and then into this photo multiplier. It looks like there's another thing that would have plugged into there, which either a dichroic mirror or a plane mirror, which would have bounced the light alternatively into this mirror and then into this photo multiplier. In the case of a standard mirror, or if it was a dichroic, you could actually have two different wavelengths going through. So I guess potentially you could see reflected light from the subject and fluoresced light, possibly. I'm not 100% on that. So speaking of these plunger things, it looks like I'm going to have to disconnect some of these to be able to get them off. So there's a few grub screws, there's a couple of screws holding the actual main thing on, and there's also one which attaches this part to a rod that goes down. So I suspect I'm going to have to undo that. Yeah, I'm going to have to undo, there's a small grub screw on the back. So there is the photo multiplier module, and yes, there is an iris in there. I'm not sure whether you can see that just. Okay, yeah, there's not a huge amount to see in there. It is literally just a photo multiplier tube, and it looks like there might be a mu metal shield on there as well. So what I'm going to do is just remove these screws, and I think it should allow us just to slide the tube out, at least enough to find out what tube it is, because these I should be able to resell on eBay, especially as they have this iris control in. That's quite a useful thing to have, actually. I would think, on a photo multiplier tube. Okay, there's the photo multiplier. Interesting design on the front there. I've not seen that before on a photo multiplier. Not sure what that means. We have a Thorn EMI 982B Bo6, or is that 9828 Bo6? I think so. So, yep. Well, what we'll do is put this back in and then reassemble, because as I said, I should be able to resell these on eBay, hopefully, and get a little bit of money back. I've just removed the second photo multiplier, and there's that little piece of plastic. It's nothing special. It's literally just a screen cover thing. Just pushes in there. So yeah, nothing interesting there. You can actually see the iris a little bit better because this doesn't have that shroud on. So yeah, that just plunges in and out and controls the iris. Let's have a look now at the Galvo assembly. So it's just a cover here, so we should be able to take that off. So yeah, very simple setup in here. We have the laser coming in through this aperture that will then point onto this mirror attached to this Galvo. That will reflect onto that one. That will then reflect onto that mirror, and then that will then reflect onto this one. And obviously, these are in two different orientations to give us your XY scanning. Now, if I just get one of my junk lasers, I should be able to show you the path. If I get this right, I might have to turn the light out. So trying not to shine myself in the eye. If I aim this through at that first mirror, not quite there. There we go. So the point, there we go. So the point that's there on my table now is the output, and you can see, you might be able to see the path. Possibly, maybe. So the actual motors are made by General Scanning Inc. and their model G120D. I've looked these up on the interwebs, and they do seem to be quite a common Galvo motor. So yeah, this box in its entirety should be, I should be able to pop that up on eBay, and it could make a nice project for somebody. Next to look at is the photo multiplier power supplies. This is Thorn EMI MPS1600N. I've looked these up as well, quite a common one. They have a variable output from 500 to 1600 volts, I think. So yeah, quite flexible. These are the N version, so they're the negative. So that is 500 to 1600 volts negative. So again, these will be going up on eBay. I'll probably sell these with the actual photo multipliers. They'd be quite useful to have as an all matching thing. Right, lastly, let's have a look quickly at the circuit boards. This is MRC600 MISC functions, so this attached to the single wire which went to the photo multipliers, so I think this just turns them on and off. Or it is the variable voltage control. That's probably more than likely, actually. So you can control the voltage of the photo multiplier through the system. So that's probably what that is doing. We have two identical boards. Each one of those drove one of the Galvos. So there's obviously a load of stuff on there. Weirdly, it's like entirely through hole apart from one random surface mount resistor. How bizarre. So yeah, those two boards are identical. These are the MRC600 amp boards, so these would have done a bit of amplification and conditioning for the photo multiplier output to go out over a cable to the thing that does the actual digitization, because this doesn't look like it does that. It looks like it's all just straight analog stuff. Well, I think we've reached the end on this one. Certainly this was interesting, yet unsurprising in a way. It didn't need a lot of thought to figure out what might be inside, but certainly was a very well put together thing and probably cost a fortune back in 1992. I'd like to thank my patrons for their support and all of you who subscribe, watch, comment. Thank you all. I'm going to go away and salvage a few more components and get them listed on eBay so we can hopefully make a little bit back if none of my patrons want any of this stuff. So thank you very much and bye for now.